Good afternoon to Sainath, sir.
Yeah, hi, good afternoon.
Thank you, sir. Yeah, sir, we are hearing. Thank you.
Yeah.
Thank you all for coming and joining here. Now let us introduce our resource person for this session, Mr. Sainath, who is an avid researcher and programmer keen on computer science and electronics. He is a passionate developer and technology evangelist with a wide range of experience in software development, test automation, cloud systems, blockchain, and full stack development. He has been uh, he had been into different roles in the software industry and have extensive experience in working with financial institutions, trading, and online banking applications in terms of design, automation, and integration. He was also been a startupper and have won the interest of investors in many hackathons and innovative challenges. A professional speaker and have addressed many gatherings on various topics like programming, career guidance, management, and social activities. Let us all welcome our resource person today, Mr. Sainath. Over to you, sir.
Yeah, thank you, Dr. Neela and the rest of the members. So it's pretty late in the afternoon, I hope, and hope all of you should be, dozed off after having quite a good lunch, and hope all of you are doing fine, and all the family is safe. So without further ado, let me go into my presentation. So let me quickly share my screen so that let me know if you have some viewing issues. Okay. Thanks for the warm welcome, and I'm happy to be here in the part of the occasion. And talking about technology and its advancements is always interesting and fun, and sharing with the peers is also it's kind of reminiscence is what I feel. And there are so many facets in blockchain as a whole. I mean, like it's kind of contaminating. If I look back in the 10 years back down the lane, or I mean even in 15 years ahead, I think like even that'll be more interesting going on. It's like it started way back in 2010 or so, and now we could see the traction is kind of humongous, right? So it has built up a lot of community, and the platform is wide, and so many platforms has come up, and it's quite a lot of interesting things are happening around the same blockchain and other technologies as well. One good thing I find is like the term chain is kind of interconnecting a lot of technologies these days. Like no other technology has linked a lot of other technologies. Say like AI or ML used to be a separate subset, or else web dev will be a separate subset. It doesn't correlate at all. But in terms of blockchain is kind of an integrating factor. It pulls, it attracts a lot of technologies along with it. So, without further ado, let me go into the brief introduction. So, yeah, you have been told about me, but still, let me tell you a brief about me as well. So, I'm a blockchain specialist. So, I work predominantly in private blockchains, means permission to blockchain. So, into Hyperledger Fabric a lot, and fewer instances into Ethereum and other open source and other permissionless platforms as well. So I started as a principal software engineer. I'm also an automation architect and as a web developer, a full stack web developer. I have recently proposed a blockchain platform on which we made a small POC, and it went well, and we did it as a startup, which is mainly on KYC. It's a platform on KYC that entirely targets the audience in Italy and pan Europe, and that went well. And it's a prototype now, and still we are awaiting for further proposals. And I've published a couple of papers during my college and even during my earlier years in my professional career. And yeah, I do speak at tech conferences, and I'm a coordinator of multiple hackathons and workshops. It's a small thing about me. You can find me a lot in my website, chinathramanathan.xyz. Okay. Without boring further, let me go into the slide. So obviously, I know the topic, the whole agenda is on Internet of Things. I mean, like you'll be hearing a lot about the facts, like how Internet of Things are connected and what are all the endpoints are available, what are all the infrastructure that is available for running your IoT devices and so on. So in general, what comes to our mind is nothing but it need not be intelligent, right? So every thing that we see, the Internet of Things, is nothing but the thing can be anything. Like it can be you, or I mean, you give out data in terms of you give out data physically as well. So you are a thing, but not connected to internet. So you are a separate element. But the other things that you use, like whatever garments you wear or whatever devices you have, it's kind of it's propagating data about you, not about you as such, but a metadata of you. Okay. And there are things, a thing can be even an organization, or even a small object, or even now we have some rovers that is already going on in the Mars, and sending us data about the soil and about the vegetation and about the habitat livability and so on. So all these are some metrics and data points that you will find it very useful in making a concrete decision. So you'll all these elements will give you a intellectual capability to decide whether to move to Mars or not, is what all things about. So pretty much everything that you see connected over the internet is nothing but Internet of Things, be it your laptop, PDA, or whatever it is, right? So in a nutshell, I will just to paraphrase the definition. So the Internet of Things refers to an infrastructure of interconnected objects, right? So the term infrastructure here is very important because that is where we are going to further investigate on, right? So infrastructure of interconnected objects, and the two keywords that are mainly important is intelligence services and the process information. Okay, we are not alone focusing on the infrastructure or as a platform, but we are focusing on the intelligent capability. Intelligent capabilities is where machine learning and artificial intelligence are going to play a huge role. And IoT is just a it's a middleman which is allowing things to happen. Okay, and we don't stop there. We do analytics, we do post analytics, we collect the data, we process the data and make it fine tuned and derive insights from that. That's what we call as analytics. So all these key terms are going to take us into something more interesting and something more most important to focus on. And it is highly, how could I say, it's contagious. I would say it's contagious. See, once you start seeing data or you start seeing insights of something, you'll be contagious. You will start thinking about a lot of other things. Like you will start looking for data from even from what to say, even from a bag, from your shoes and so on. So that's what happening now. Okay. So have these keywords in your mind: infrastructure, interconnected objects, intelligence services, and process information. Okay. So what do we actually see in the normal scenario? See, like I have plethora of devices, right? So there are humongous number of devices. So you as a person, you yourself have smart glasses, you wear smart watches daily, and of course there are smart shirts as well. I mean, predominantly you could see everything that you prefix with the keyword smart becomes smart. It be a smart shirt, smart shoes, or whatever. But what you do predominantly is use very few aspects of it, right? So probably you might be using smartphones or a smart wearable device on your wrist, smartwatch, right? So you could have seen that, for gathering all the insights. Say for example, you have a smart band in your hand and you just want to see all the metrics. So what are all the metrics that your smartwatches give these days? SpO2 count is being given, and heart rate is being given, pulse count is being given, even blood pressure is being measured from your wrist. So everything, every data of yours is being derived. So we are not stopping there, right? So all this data is being captured from your body, but where do you store it? Where do you transmit it? So that is where comes the applications, right? It's being hosted in the cloud. It's being developed as a mobile app or a web app, is where you will monitor yourself. So every smartware or wearable device provider will give you with an application to use specific to your operating system, be it Android or iOS. So I have a specific app where you'll have to log in, create a credential, and you will have a separate allocation for yourself, and that is where you could see all your data. Imagine that I collect 12 months of data of yours. I can easily tell what kind of person you are, whether you are a kind of a person who is always agitated, or you are the one who's always calm, or even you do have irregular sleep habits. I mean, imagine the analytics we can go on with the data that you have. Okay. And so many people, they fail to understand these aspects. Many of, you would have seen about Google Home, Amazon Echo, and so on, right? So all these devices work on data. They are data mongers. So like they literally feed on something in order to improvise themselves, right? So imagine a Google Home or Amazon Echo is accepting your voice commands. Basically, those are smart speakers, is what it's being marketed. But these are something which is always on for you, right? So I never put it on. I make it on whenever I need. So likewise, but no other people recognize that, right? So they keep it on. So all the time, what happens is like it'll observe the conversation happening everywhere. Like I'm speaking with it, and invariantly, without me speaking to it deliberately, it can listen to inputs that are happening around. It can listen to the environment noise. It can listen to the sounds that people make, that our kids make, or it can even listen to the talks, that sensitive talks that people make each other, or some financial talks that they make. Imagine the data that they hold, which is in no control with you, right? So they have a separate storage, and they have a separate mechanism where they hold up everything. And things, there are other things that we can't go in detail of. Other things, like there are smart refrigerators which can tell you what are all the fruits and vegetables available in your fridge, or what are all the dairy items are available, what temperature is it being set at, what is the maintenance aspect of it. Everything is being recorded in a small microprocessor, and it is relaying you data consistently. So all these put together is kind of a data generating devices, is what we can say. Okay. And of course, automated car is not available now, but still it is always available in the US first. And you could see how it is able to park itself in the rear, and it could self drive, self autonomous, it's autonomous vehicle, and so on. So there are plethora of devices, is what we have to take away as the lesson from this. So there are two aspects. It doesn't stop in consumer point of view. It is also applicable in the industrial point of view. So automation is not to ease end user. I mean, the end user is nothing but us, not us alone, but even the corporates, right? So even for the industry, you have a metro train which is self-driven, it's just autonomous. All right, and we have some factory. The car manufacturers use robotic arms to assemble their cars. All these are automated, so it's typically connected through a IoT platform. So what are all the characteristics we'll have to observe from this, right? So we need to understand some teeny tiny factors of what are all the important things that IoT is focusing on, and what are all the pain points of it. So that is where we are going to solve some intricate problems which will make better, make our lives better and make it secure. So a thing, I mean, it can be anything. As I said earlier, a thing, connected object, it can collect data, right? So that is one of the characteristics. And each object should have a unique ID. That is how we will know what it is. Correct. So what if I have a temperature sensor, or a barometer reader, or a potentiometer, whatever? A list of devices should have a separate unique ID to it. So even if I have a laptop, it should have a unique serial number to it. Okay. Then how it collects and shares data is also very important. Okay. It should have a mechanism of how it collects and how it transmits data. And some objects are programmable, right? So not all are programmable. Say your washing machine or a smart refrigerator is programmable, like you can program with it, or it has a microprocessor which with a set of instructions, and it will carry out based on the instructions that you give. Okay. Some are not. Some are like it's very static. Say your grinder or your mixie, whatever you use in your kitchen, might be static. It doesn't have any intelligence with it, right? So some object can make certain decision without human interference. Say like your smart refrigerator. I can come back to it because, say for example, in the US, it has, all smart refrigerators are connected with the Amazon marketplace. So if at all I could find some vegetables are getting low or some fruits are getting low, it can immediately place order based on the instruction that you have already set. Say in trading, there is something called limit, right? You can set a limit, at a limit where it can buy or sell, right? So that is how it works. So you can set an instruction. Say if I got only, if it comes down to 2 oranges, then make an order of another 10 oranges, is what you can tell it. So that is called decision making without any human intervention. Okay, so let us see the primary aspect of how these interactions are happening. Okay, basically, if you could see, like, normally it happens to thing. Okay, I'm not sure if you have witnessed it, but say for example, based on a thermometer, say a pretty much example, a straightforward example is nothing but your automatic motor turn on and off, right? So you have your tank. Whenever your tank is filled to a certain extent, the motor gets switched on and off. It has a relay in it, right? So anyhow, it has a relay in it. Imagine you have a sophisticated system where it is wirelessly connected, and whenever the motor is, I mean, when the tank is full, it'll it'll pass on some signal, say in binaries, to the receiver or the transponder or whatever it is. It'll receive, and it will make some decisions like on and off, right? It's pretty much straightforward. So that is called thing to thing. You don't have any middleman or someone operating on it. Next one is human to thing. Human to thing is nothing but you opening a car, you opening a car window or a car door with a remote lock, or opening your garage door with the remote, or your controlling your switches, I mean your bulbs and fans with the remote, is what human to thing. Human to human is nothing but you have a service in between. Okay, so a typical example I would say is your mobile device. A mobile device is nothing but an interface between a human to human. Okay. So you put IoT in middle of you so that you can converse in a way that you could understand, and machine acts as a simply like more of a middleman. So this is all about interactions. So basically, it is thing to thing, human to thing, and human to human. Okay. So there are a lot of communication protocols. So we might know a few, we might don't know a few. Okay, there are Bluetooth, Wi-Fi, NFCs. NFCs are near field communication. So normally you'll be using NFCs for paying your cardless payment or contactless payment, right? Even you have in your phone where you could read your card and use your phone instead of using the card for payments. And there is LoRaWAN. LoRaWAN is a low range wide area network, cellular, and some other connections. Some other protocols are, it's kind of more centric to the industrial parties. So these are the communication protocols over which the Internet of Things is connected. Fine. You can pass me anywhere if you have any doubts. Let it be an interactive session so that we can go on well. Okay. So I was going through the Gartner data and some other statistica where I could see that the users who are spending on IoT solutions is kind of increasing. So I could remember way back, 10 years back, people were saying like, automated things were cool, and they never ventured into it. They would just sit back and view as a super, what is a science fiction movie, but it was never meant to be realistic. It was all filmy. But now, having things, having improved microprocessor and other things in a capacity where you could have a 1 TB of memory in your hand, everything is possible now. So now you could see people's interest, people in the sense it involves not only the consumers but also the industrialists and other people. Their investment on spending on IoTs is kind of increasing. It's exponentially increasing. And you could see now there are 50 billion devices, Internet of Things, that are connected. So across the world, you could see 50 billion devices communicating with each other. So you can even think of a situation where it can even surpass the human population as well. So that is a kind of growth that's happening. So this figure makes a very strong command that IoTs are most needed or most viable, or even it will become in a way that those are the things without which you can't live. Okay, so that is a core philosophy we are trying to understand. So why there is a necessary or why there is an importance in focusing on internet of things is very important. That's what I want to highlight. Okay, being all said, so everything is cool. So what is the area of blockchain? What is the role of blockchain here to play is what you might wonder. This is where we'll have to focus on something important that I reinstated in the beginning of the slide, where we are dealing with a lot of different factors. Okay, the main thing is data and information processing, analytics, and so on. So now, having seen so much of background about IoT, we'll have to come to a conclusion where the ever growing number of IoT devices means data vulnerability. Okay, so we are interested in using the IoT, but we have never thought of how to secure it, because even a simple web application with wherein a financial application or whatever it is, if you simply have to log into it, you have an authentication mechanism for it. A simple website has an authentication mechanism with OAuth or password, whatever it is. Okay, so for even such a simple thing, you have some security, but you don't have any security for IoT is what a major concern across the industry. So now, why this topic is because of the data vulnerability. That is the key takeaway that we are going to discuss further. Okay. So what do you see as a problem here? Any guess on what's the problem I'm trying to talk here?
Data security.
Okay. Seeing. I'm sorry, I didn't put it right. So if you could see the picture that's being shown. So what view you have on the picture? I mean, what is it trying to imply?
Traffic information, sir.
Hello.
Is it traffic information?
Yeah, that is one. Any other thoughts? Any other thoughts you have?
One participant mentioned as connected devices.
Yeah.
On the IoT enabled devices.
Yeah, exactly. So thank you. So what we are trying to imply here is, we spoke about automated cars or self-driving cars, right? So it involves a lot of sensors and a lot of receivers and so on. So what it necessarily needs, say you're sitting behind the wheel and you're not driving, and you're sipping your cup of coffee and looking outside. So you're in a highway, and you believe on your car that your car will be safe and it will take you to the desired place, right? So on the course of action, the car is making intelligent decisions on behalf of you. Say your human brain is so intelligent enough, it can take very quick decisions, but you can't replicate the same in terms of IoT. You have a lot of parameters for it, right? So as a car which has a sensor and a receiver, it has to have a vision. So it has to look at different objects and count the distance of it. It has to come to a conclusion of what range of speed should it go on. It has to look at the signboards and fix my accelerometer with say 60 km per hour, and it should not rev more than that. Okay, there are so many aspects to it. Say what if a deer crosses or a lion crosses, then also you have to set some parameters where it should quickly stop, or it should slide away, and so many different parameters are there. Imagine if this is going haywire. Okay, and it's not working, some of your sensors are not working, then ultimately it will result in a collision. Okay, so this is where the data integrity and security is more important. Say, what if someone hacks into your car and they are able to drive it? Okay, that's a kind of worst scenario. So this is the place where we'll have to more focus on how to make it interoperable and safety. So the main approach that I am trying to tell here is that the integrity is very important and the security is very important. So the main takeaway here is integrity and security. Okay. The second big problem I see is what you could guess on seeing this picture. Any thoughts on this? Anyone? Any thoughts on what I'm trying to tell here? All right. So the second problem
One
is
faculty mentioned as e-commerce.
e-commerce. You mean the Amazon?
Yes.
Okay, fine. So what is the e-commerce that you're trying to tell? What is the problem there?
One more answer as supply chain.
Sorry?
And supply chain and inventory management.
Okay, that is a concrete one. Okay. Supply chain inventory management. Yeah, those are some problems, but these are something more specific is what I'm trying to tell. So you could see the very straightforward example is Apple. All that you see here is nothing but ecosystem. You know, the Apple ecosystem, it has all the devices interconnected with each other, but it never supports devices out of it. Yeah, an Apple Watch, it can't communicate with the Windows machine, or it can't even communicate with your Android mobile. It's strictly tailored to connect with your iPhone or your iPad or your Mac. It's not even with your iPad or your MacBook. It's only with your phone. So if you want to buy an Apple Watch, you'll have to buy a phone. There's no other go. And if you come to Amazon, it's strictly stick with its own plethora of services. It'll it'll get you connected with AWS. It'll get you connected with Amazon Marketplace, which is nothing but the shopping. Okay, it can't go out and say what's your order in the Flipkart, what's your order status in the Flipkart, or it can't go out and say, you know, it can't go and. Of course, it can search Google, but you can't go and read your mail unless you give access to it. You'll have a third party in between and so on. So all these conglomerates, okay, they have their own way of designing things. They have their own ecosystem. So it, all I could say is this is more of a Web 2.0. Okay, we are going towards Web 3.0. So where interoperability is the primary concern. Okay, so the kind of locking mechanism is the biggest problem we find in Internet of Things as a major player. So the first thing is about okay, the automated cars which should have integrity, and the security is important. Third thing is about interoperability. Okay, so having gone through all this problem, we can come to a conclusion that two major aspects is very, very important for any IoT, which is nothing but the identity and access. Okay, all I need is that the identity of every device is important so that we can interoperate between devices, and access can be controlled, and the entire access can be given to the user. The user holds the entire administration for the access. So these are the two topics that we are going to delve further, and how it could be implemented in IoT is what I'm trying to tell you here. Okay, are you clear of the context that I'm trying to set here? Any doubts on this so far?
No, sir, it's fine.
Yeah, thanks. All right. So, having spoken about identity and access is predominantly how there are two factors. There is two things called authentication and authorization. It's completely different terms, and people confuse it with each other. Authentication just tells you who are you. Authorization tells you what you can really do. Okay, as a person, as Sainath, what I can have access to. I can read file or write file is what my authorization is. Authentication is just tells you this is Sainath, who's a software developer in Maverick system. So, what is the current problem here? So, you could ask me, Sai, okay, all this is fine. So, why should I bother about identity and access management here? People are already using single sign-ons and so many other stuffs like Google sign-in, Facebook sign-in. A lot of plethora of services are available there, right? But the problem is, it is being held by a single conglomerate. Conglomerate here is a big corporation, is what I would say. Amazon is a big corporation which is an umbrella organization, has a number of products and number of services under its umbrella, starting from AWS to Amazon Marketplace to a lot of a lot of things, right? And Google as such. So these uh, conglomerates or companies hold your identity, correct? So let me put in fact, it could tell you everyone has a default mail ID as Gmail ID, right? So no other people you could see here having a Yahoo or other than official ID, your personal ID is going to be just Gmail ID is what the de facto here. So what if Google shuts down someday? Okay, what if people decide to shut down Google or something happens? You'll be ID-less, right? So what happens to the IDs that you are given as a part of KYC to banks, financial institutions, and other places? You have to go and redo all the steps, right? And the biggest thing is having a phone number as identifier is the biggest mistake now. Okay, people are changing phone numbers. It can't be your unique identity. You have to hold on to it until something becomes unique. So this is the biggest problem here. The access management is controlled by only one set of group. Okay, that is a big blocker here. So what are we trying to do is we have to decentralize it. Okay, so how it works, let me tell you a smart workflow of how it happens, and I'll tell you what actually is decentralized identifiers and what is decentralized identity. You understand about identity, right? So what is identity? Basically, you have your Aadhaar card is nothing but your identity. Aadhaar is something different. It's quite unique. You can't talk about it, but just it's a representation that I belong to this country and I have a unique social security number, which is nothing but my Aadhaar card. So I have my passport, which tells I'm a citizen of Indian country. Okay, and so as you know, if you have a workplace card, like if you are employee of some organization, you'll have a card saying you're employee of your organization with the employee ID. Okay, but now what happens is that um, I'm not sure how many of you have been exposed to back office operations in financial units or somewhere else. Okay, if somebody submits a KYC document or something, there is a humongous amount of activity happening in the behind about cross verifying if the document is unique or legit. So it might be easy for you. Say, for example, a simplest use case will be like, if I go and join a new organization, if I'm going to join a new organization, I have an offer, and I'm going to enroll myself in that organization. Say Google. Okay. So what Google has to do is Google has to verify. They have to completely vet me in order to accept as their employee. Okay, so they have to vet me on criminal files. They have to vet me on if I'm a citizen. They have to vet me on my career, whatever career timeline I had. So with my previous employers, my date of birth, my school grades, these are all the information they have to take along in order to verify me and pull me in, right? So imagine the process kind of happening there. So this is kind of huge, both for the the person who is actually doing it, who is vetting it, and for the person who is actually giving it. So you will also have to redundantly give out all the documents every time whenever you go for such activities, be it anywhere. So this is where decentralized identification comes into play. Okay, so what they have narrowed it down is nothing but, say, imagine you have Alice over here. So Alice, she has to visit a hospital. So what if she want to visit a hospital? What is the basic primary need that a hospital would need? Okay, say for example, she's going to get herself checked up for a routine health checkup is what she's intending to do. So what they will ask for is her primary card, I mean, some verification, right? To know if she is really Alice and to know her age. Okay. And what they would ask is few parameters like name, first name, last name, age, and preferably sex, and some other parameters if they have some previous disease or not. Okay. So that's it. They don't essentially need where you are working and all. Correct. So the parameters are limited here. So what the insurance company needs is to know about your previous health records as well. Okay. And they definitely don't need to know about your employee details and all, unless or otherwise you are employed with an organization who is going to cater for your medical insurance. Okay. And my smartwatch is going to give me a real-time data of what is my actual scenario is. It will give me the pulse rate, it will give me the blood pressure, which I don't need to share with my friend Carol. Instead, I can share it with the hospital because they are the ones who actually need the data to treat you. Right. So we are completely decentralizing it. So the point I'm trying to tell here is we are decentralizing the entire identification factor where you hold the entire authority to give access to other people. You don't need to rely on some major parties to make yourself legit. To put it simple, it's up to you to give access to them. Say for example, if I want to give my health records to the hospital, I'll give only access to them, not to my friend or not to my smartwatch or not to my insurance company. So the complete control lies with you. Okay. So this is where we are decentralizing it. So we'll go a little bit deeper. So a decentralized identity is nothing but this huge string you could see here. So a decentralized identifier is a new type of identifier. So it's globally unique and it is resolvable with high availability and cryptographically verifiable. So I'll define you what it is actually. So this is an identifier. Imagine you take, for example, my email IDs, SANADH r@mavericksystems.com is my official mail ID, which represents the first few characters represents my username at the rate of the domain I'm subscribed to. Correct. So my domain is my organization. It's nothing but mavericksystems.com. So something like this, you'll be created with a decentralized identifier. So identifier is nothing but DID is a unique. It's a scheme. It will be followed consistently. So this is a common terminology that you are supposed to use, and this is a DID method. So method here is nothing but what sort of method you are going to apply in order to generate the identifier, which is nothing but this pretty long string. So this is an alphanumeric string. Okay. So this alphanumeric string is nothing but the unique identity that will be generated to you based on the method that you describe here. So what is that method that you are trying to do here? So what is the method is nothing but it is going to be run on the blockchain platform. So that is where you are going to solve and produce this string. So it can be a sovereign platform. It can be an Ether platform. It can be where is one platform. So there are some 5 to 6 platforms on which you can create your own decentralized identity. Even now, you can set up your own blockchain platform and you can create your own unique decentralized ID. Okay. So all that I'm trying to tell here is nothing but a decentralized identifier is nothing but a long string. Okay. It's an alphanumeric string which is generated by means of a method. So that method is nothing but a blockchain platform. So for example, you know what is a blockchain, right? So in order to have a transaction executed, you will have to perform some work. It can be a consensus or a proof of work or proof of whatever. There are so many consensus mechanism. You have to apply those consensus, and out of the value of it, a block will be created. Okay. So in order to create this specific string, you'll have to create a method in order to generate this specific string. Okay. DIDs are a beautiful aspect of DIDs is like you can create any number of DIDs. But when you are tying up with an entity, it's entity in the sense it can be an organization or it can be even an individual. Okay. So when you are connecting with an entity, there will be only one single user ID that will be connected. Okay. And it is completely peer to peer. So the entire channel is highly encrypted. So only two of you will be connected, and two of you will be passing relevant data. Say, as I said earlier, I don't need to send my employer details to the hospital. Okay, I just need to tell them what is my name, what is my father's name, or my wife's name, or whatever it is, and my blood records. That's all they need to know. Okay, so the kind of control is where you possess, and you are the authority of it. Okay, so what is this DID is so simply it is an identifier. Okay, there lies a lot into it. So which is called decentralized identity document. So what is a decentralized identity document? Decentralized identity document consists of an ID, which is nothing but probably this is a unique identifier that you saw here. Okay, DID example. This alphanumeric string is what you are seeing here. So this is your unique ID. Okay, so this DID document is nothing but a JSON. So JSON LD document is what they will say, linked document. It's a pretty long document. It will have every metadata of what you're trying to see. Say, for example, Sainath as a unique, I have a username, okay? I have some unique decentralized identity. And if I have a look at my decentralized ID document, this is called as DID, I have a lot of parameters in it. Say I have a public key. Okay, this is the public key that another identifier will look upon. So in order to, so how do you find someone? You find someone with the address, right? So how do you reach me out? You reach me out with a email ID or a website. So a public key is essential in order to communicate with each other. Okay, so that is where I mean, another person X might have a public key, and I have a unique ID for it. So the public key is necessary for me in order to communicate with them. So that is what a public key. Okay, and a type of authentication mechanism. What type of authentication you are trying to use? It might be RSA, or if you are using some encryption mechanisms, it goes in here. And what are the services? This is very important. So service is nothing but what service you are trying to say. For example, if I could put it simpler, you have a unique URI, right? So URI in the sense, in APIs we call it as URI, unique resource identifiers, or in general you have URLs, okay, unique resource locators. URIs are pretty much straightforward. So https example.com is the URI. Whatever comes after the backslashes are nothing but the resources. So if this is a domain in which I have further resources like endpoint is a resource and 1576358 is a resource. Okay, so this tells that I have access to these services. Okay, even that is mentioned in my metadata. In the sense, say for example, if I have connected my smartwatch to my decentralized identity, it will come as a service here. Okay, so whatever service you are connected with, it will be listed here, but there is a clause. It can't be seen by everyone unless or otherwise you approve it. Okay, it shows only relevant information. Say I was telling you earlier. Okay, let me finish this. So you have created timestamps. So whenever and where you add a service or remove a service, a timestamp will be created, and a proof. This is a digital proof. Every time you do this, a proof will be whenever you sign it with the RSA signature. There is a proof which happens, and it is recorded. Okay, a proof can be anything. It can be a consensus mechanism or anything. Okay, so I'm pretty much interested in telling you about the service here. So this is the service I said you about, right? So if we could go back to this diagram, I have a lot of services here. I have a smartwatch service. I have a connection with insurance company and so on. So when they request for some parameters to focus, say if they want to access my health record, they can just simply go to example.endpoint/health. If I have a service here and if I have something called health, they can only access that endpoint. They don't need to access some other endpoints. Even if they try to access it, it is tamper evident. In the sense, it will be easily visible, and you can very much revoke the access from them. Okay. So this decentralized identity document or decentralized identifier is alone not enough. You also need something called verifiable credential. Okay, this is something like okay, boss, I trust your blockchain system, I trust your entire mechanism, but who's the actual propagator of this? Who's the actual issuer of this is the primary concern, right? I can't simply print myself my visiting card and go and just give them that simply to contact me is fine. Okay, but can I simply put it as Google and give out my number? So if you want to speak with Google and reach me out, you can't say that, right? So if you people will pretty much know that if you have to speak with Google, they should have an official number, or there are other means of contact to it, right? You are not a what to say, you're not accredited by any issuer, you're not accredited by Google as one of theirs, correct? So here comes something called verifiable credential. Okay, so let me tell you the definition first, and I'll explain you in detail about what is a verifiable credential. So verifiable credential, as I said earlier, is a tamper evident in the sense you have seen boxes which are sealed, right? So I mean, you could even take the example of a mobile phone box that comes up. You know, there is a seal. You could find a seal being sticked at the ends of the opening. You can't open it unless you break the seal. Okay, and there will be an important notification over there saying like, you know, if the seal is broken, never consider buying it, is what they will say. So it is tamper evident. It's evident that the seal is broken, correct, and you can't do any malpractice on it. So that is called as tamper evident. The verifiable credential is a tamper evident because I stated earlier that everything that you do in this decentralized platform, it gets recorded in terms of public keys and private keys. That's where cryptography come into play. Everything that you do is recorded here. Okay. So a verifiable credential is a tamper evident credential that has authorship, which can be cryptographically verified, and VCs attest identity attributes of subjects, and exchange of VCs build up trust among the AD identified peers. Okay, enough of definition. We'll see what actually happens here. Okay, so imagine that I'm the user, and there is an issuer. Okay, imagine that I'm enrolled to a college. Okay, I'm enrolled to Mahendra Engineering College, probably. Okay, and this verifier is nothing but the current company that I'm working, a Maverick System, can take into consideration. What I need actually is my company is asking for educational record. I'm stating that I have got 8 CGPA in Mahendra Engineering College, and the organization wants to verify that. So what usually happens is, in a usual case, you'll do a physical copy of you'll do a photocopy of all your physical certificates and submit them, and in turn, a long process will happen, and you are verified. But what if the same thing happens digitally? Okay, so what happens is that the issue every now we know what the digital identifier is. So I have a digital identifier, the issuer has a digital identifier, and the verifier, it's nothing but the organization who's requesting my document, is having a digital identifier. All these are connected in a blockchain platform. Okay, so what it does is the issuer says it gives a claim. It's a claim. Okay, the keyword is important. It's a claim saying that the user Sainath is enrolled in my organization. He has such and such age, and he has completed his master's degree with such and such CGPA is what the metadata or a payload will be passed along. Okay, it will completely write all these data, all this payload, and sign it with the digital signature, and the complete thing is converted into a hash and stored in the blockchain. I believe that you know what is hashing, and what the blockchain is, how it works. I'll brief you about that in coming slide, but still remember this. So in a hash format, your entire data is stored in the blockchain. Okay. So what the verifier does is nothing but asks for the proof of my education, correct? So what I will do is I will pass on my digital identifier with the verified credential. Okay, I present my verified credential to the verifier, which is nothing but an organization which has a hash in it, which is nothing but a hash, which is in the blockchain. Okay. What it does is it goes to the blockchain and gets the public key of the issuer, and all the authentication mechanism and all the cryptography mechanism happens, and it able to decode if both the hashes are same. So it will do its own hashing and verify if the given hash that I have given and the hash that they have computed are same. Okay, if they are same, then it is perfect. You don't need to worry about going back, doing all the paperwork, making a number of calls, and verifying if I am a legit candidate. So it all happens seamlessly. So what happens is nothing but they write all the data, and they post all the credentials. They hash it and store it in the blockchain. What the verifier do is they go and do the inverse process of, they create their own hashing based on the records that I have submitted, and they'll compare the two hashes, saying if they are equivalent, then it's fine, you're good to go and you're enrolled in the company. So as simple as it. So verifiable credential also has a JSON kind of document. It necessarily, okay, so a digital identifier, decentralized identifier, happens to be in the format of a JSON LD. LD is nothing but linked document. Okay, a verified credential may not be a JSON. It can also be a JWT token, or it can even be a payload, XML, whatever format. Even digital identity or digital certificates are available even now, but it's often in a different format. Okay, the best example I could say is our government is having this common single DigiLocker is the best example I would say. It's I'm not sure if it is decentralized, but it is the best way of authenticating yourself or identifying yourself. Okay, it has all the metadata of it. Okay, we are far ahead in implementing such technologies, but the only thing is we have never done it in a blockchain platform. Rather, we have a centralized repository where every manipulation is happening. So coming back, a verifiable credential will have ID, which is nothing but the unique identity of the issuer. Issuer is nothing but your Mahendra Engineering College. What type it is? Okay, it's a name credential or a educational credential or whatever. And who's the issuer? Issuer is nothing but Mahendra Engineering College. Issued on date. What is the claim? This is very important. So this claim tells me that I have been qualified and I am accredited. So I've been given a master's degree from Mahendra Engineering College. This is more than enough for any future companies to pull the records. Okay, and they sign it with their own digital mechanism. As I said, cryptography is entirely different subject where they will sign with the digital signature, which is more than enough to verify if the issuer is valid or not. Okay. Any doubts until this? Because this is a core concept on which we are going to correlate this with the IoT. Any doubts?
Sir, you can continue, sir.
Yeah, okay. So I just wanted to mention about this DID auth. Okay, I'm not sure how many of you are aware about the OAuth, and there is simply auth and simple there are simple type of password mechanisms and so on. There are so many other different type of authentication mechanisms, but decentralized identities require a separate authentication mechanism in order to validate themselves. So imagine two different decentralized identifiers are talking with each other. So how do they authenticate? Imagine that um, you know I'm not sure if you are aware of the wallets and all, the digital wallets. So wallets are nothing but a placeholder of your private keys. So wallets is where you will hold your private keys, wherein if there is a challenge that is being posed, you will solve it and you will sign it off with your private key and their public key. Okay, this is called AES encryption, and there are so many other encryption standards. This is how it will work. So I'll try to brief you what it actually does. Okay, so imagine that you're going to log into Amazon page, and imagine it has its own digital identifier, and I have my own digital identifier. So if I have to go into log into Amazon page for the first time, what it will does is it will give a simple QR code where I can simply scan the QR code from my mobile app, which is nothing but a digital wallet they have. Okay, so what I have to do is I have to scan the QR code and profusely solve a challenge. Okay. The challenge in the sense, it's not literally you solving the challenge, but I mean the challenge that is being solved in order to create a block. So you very well know, in order to compute a block, you need to solve. Okay, there is in blockchain you need to solve a complex challenge so that a block will be formed. So that is the challenge we are talking about. So once a QR code is displayed, I'll go flash my mobile phone on that, scan the QR code, solve the challenge, and I'll once I derive the output of the challenge, I will sign it with my private key along with Amazon's public key. Okay, once I do that, I will sign it off and create a hash and post it in the blockchain. So what the Amazon will do now is, it will take the encompassed hash. It will reverse engineer the hash. Okay, in order to decode the solved challenge, what it does is, it opens it with its private key and my public key. Okay, that's how it happens. So I sign it off with my private key and my public key. It opens it with my public key and its own private key. So that is a kind of encryption happens here. So thereby, the authentication is established here. So that is the decentralized identity authentication here. As said, I don't need to explain much about the most spoken topic, and it's a cliche, I would say. A blockchain is spoken everywhere, and you know what is a blockchain? It's a connected, I could say, a beads of data is what I can say. It's a series of transactions where every transaction is solved by miners in order to achieve the consensus. Either it can be a consensus or a proof of work. Okay, the proof of work is obtained by either solving a complex problem, and the data is verified, the transaction is verified, and the link is formed. So this is a complete blockchain where you solve for every block and keep on adding the block, keep on appending the block. And there is a limit here. You can do only up to 7 blocks, and you'll have to wait. You can do only 7 transactions at a time, and there is a time lapse in it. You'll have to wait. There is a delay in it. And of course, it is being solved by other platforms. We will see it in later aspects. And I'm trying to tell some important key points here, because these are all the aspects we are going to apply in the IoT in the coming sections. So smart contracts are nothing but literally a contract which is written in the form of a code. So it's nothing but a step of instruction, I would say. You will have to say, for example, the best example is what I could say of COVID situation here. So imagine you're running a small shop or something, or you are simply a small kiosk or whatever it is. You allow certain number of peoples only based on predefined conditions. Say you write it in a paper saying that you should have properly masked, you should not have fever more than 97 degree Fahrenheit, and you have 5 to 6 instructions. You stick it outside your shop. Okay, so whoever the consumer is who's going to come by will read all these 5 instructions, and only if they agree that they have met out all the 5 instructions, they will come in, or else even you won't allow. Okay, probably imagine that you have a mini robot which is following all these 5 instructions. So that is what a smart contract does. So in order to do some necessary steps, you will write in a form of a code, it be it in a Go programming language or Solidity or whatever, and you deploy the contracts in order to maintain the mechanism happening. Okay. So now, so far we have seen about some important concepts: decentralized identifiers, verifiable credentials, which is also called verifiable claims. DID documents is nothing but the so identifier is simply a username is what you can imagine. The actual content is nothing but the DID document, okay, which is a JSON LD document which has all the metadata that is required to cross communicate with different entities. Okay, and we saw about blockchain, we saw about smart contracts. So having put all this in our purview, so let us see how we can do it in a IoT scale. Okay, so what is actually necessary in a IoT? We'll see a high level overview of it. Okay, so we need 3 aspects. One is authorization, authentication, and accounting. Okay, authorization is how, I mean, what is that you're authorized. So what are you capable of doing? Okay. Authentication is who. So who is doing this? Accounting is what. So what are all being done? So Sainath logged in this system at a specific timestamp. Sainath was browsing a website in specific timestamp. So that these are the logs that I maintain, okay, in order to audit myself. Okay, this is the high level overview. So how is the identity of an IoT device actually managed? That is number one. Second thing is, who has authorized rights over any particular IoT device? Not that, say, for example, you have a Google Home in your house and everybody comes and speaks to Google Home and makes instruction. Okay, it won't be possible unless or otherwise you register your voice in Google Home so that it will recognize you. So if I have my own Google Home or Amazon Echo, it won't be possible for multiple people to give instruction because it knows only my voice pattern so that it will respond to it. Okay, I can't simply go say, imagine that I completely interconnected my Google Home across my suite of devices, and you simply come over and say, play a song from Eminem or whatever, play a song from Eminem in my YouTube. You can't simply come and play it. So what if I'm good doing some important work and you play something? No, that won't be possible, right? So who has authorized rights over an IoT device is very important. And what costs are assessed for managing the identity of an IoT device? Cost can be anything. Cost can be literally a cost or a proof of stake or the performance or the cost of maintaining that IoT. It differs from different angle, and we'll see it in detail. Okay. So based on this, DIAM is nothing but decentralized identity and access management. So based on which we'll derive a platform. Okay, the lowermost platform will be infrastructure layer, which is a blockchain and distributed storage. We have Hyperledger Fabric or Hyperledger Indy, or there are so many different platforms over which we'll be developing our applications. So that is a base layer. Blockchain is going to be your base infrastructure layer. Second level of layer is nothing but identity management. So even in your web development, you will have multiple modules. Say you have a login module, you will have a registration module, you will have a database module. You have so many different modules, right? So in that way, you have different modules in this as well. So identity management profusely manages your identity in terms of accessing, authorizing people to authorizing devices here. It's no more people. It's between multiple devices or human to device, correct? And the next one is authentication. Authentication is what sort of access. It might be a DID authentication or simply a JWT token authentication. And the last level is authorization. It's what the control you have to uh, possess in order to operate a IoT device. Okay, so I've just squeezed up a lot, so it might be a bit dizzy for you, but still, if you see it as a story, it'll be so beautiful that you can come to a realization what I'm trying to tell actually. Different types of blockchain. I don't need to explain in further, but still, the two important things that I would like to mention is about the permissioned and permissionless. Okay, so I don't want to explain further on different types of blockchains and all, but have in mind there is two. One is permissioned, another one is permissionless. Okay. Permissioned is where the audience is limited. Okay, it might be a walled garden, is what people say. Walled garden is nothing but it's a closed valley out of which no other people can come and make decisions. The participants are all closely known to each other. Imagine I run a family business. I have only people from my family who can run the business and who can make decisions on it. So that is called permission. Permissionless is where everybody can come in. It's like something buying a stock or a equity share, where you have a very teeny mini stock price where you claim yourself that you are a part owner of a company. It's something like a holding a stock. So there are different kinds of platforms out there. I mean, even the minute now I'm explaining, there might be a platform coming up tomorrow or even now. So far there is plethora of platforms available, of which the most known is Ethereum. Okay, and which is a permissionless, which is a public blockchain platform. And the other most known is Ethereum Classic, is well known. And there are some other newbies here. And in permission, you have Hyperledger, which is an umbrella organization run by Linux Foundation and IBM together. And CURDA is more of an enterprise solution. Even Oracle invests in it. So these are predominantly, and Quorum as well. So these are some blockchain platforms who are dominating in the space of entire distributed ledger technology. Okay, so I would like to introduce you to the most famous public permissionless IoT, which is called IoTex. It's based on Taiwan, but still the platform is gaining huge attention and huge number of followers, and it's literally spiking up in terms of the number of stars in GitHub as well. You can go and visit this IoTex platform, and I have two proposed models here. So one is based on public, and another one is based on private. I'll show you. I'll tell you how the architecture will be in public and how the architecture will be in private. So for private, I'll be using the Hyperledger Fabric as a distributed ledger technology, and Hyperledger Indy for identification, or what is identity management. Okay. So coming to IoTex. So first we'll see at the permissionless architecture. So IoTex is a IoT specific blockchain platform which is trying to solve the identity and access management issues. So it's simply put in a nutshell, it's simply a blockchain platform, IoTex, where you have smart contracts, and the smart contracts are further connected to a different subsets of IoT application. So it might be an IoT device, a combination of heterogeneous combination. It might be a heterogeneous combination where you have a IoT device, a mobile app wherein you could access the IoT cloud, okay, and IoT cloud where you can store the DID documents, okay, decentralized identifier documents. Documents is what the JSON LD document that I specified. So this is a simple architecture. Okay, there are other aspects into it which I would like to tell. So first, in the case of architecture, just a minute. Okay. So first, in this architecture, you could see like a complete blockchain platform with the smart contracts are connected to an app and further connected to a IoT cloud. Okay, so let me tell you what is happening here. So I have already told you about the DID architecture, where how the process will happen. So initially, what happens is that every IoT manufacturer, say there are many number of players in the IoT. Like you have OEM separately, right? Original equipment manufacturers separately, and those who are assembling it are different, and the number of spare parts are kind of huge. Okay, all this come together. What happens is like you'll have a base platform in which there is something called IoT manufacturers. So these IoT manufacturers, they will come and enroll themselves in the blockchain platform, which is the IoTex platform. Okay, I'll stop saying IoTex now because you will already understand what I mean the platform. So first, what they have to do is they have to come and enroll themselves, and they have to write their own smart contract and publish in the platform, for which they'll have to shell out some stakes, which is nothing but the crypto coins here. IoTex has its own cryptocurrency, or you could call it as a crypto coin. So it has to shell out some coins in order to register themselves. So you might ask me, these crypto coins in order to register themselves? It's because to enhance the quality. Say like if someone randomly comes and joins, because this is a permissionless network, and you can't simply put a very low cost, or not even a low cost, low performing, or not even a worthy product in the ecosystem, correct? So you have to be cautious. And this is something like, if something is for free, it won't be of good quality, is what normally people will concern. So that is where, in order to ensure the quality and performance of the IoT device, you have to shell out some crypto coins and enroll themselves. So IoT manufacturers would have enrolled themselves, and they have a separate smart contracts, and they have a unique list of digital identifiers for every device that they are enrolling. Okay. The second thing the platform as such has is a smart contract, the list of all manufacturers. So there are two smart contracts here. One is the manufacturers who are going to list their own set of instruction. That is, those smart contracts specific to manufacturers, and there is a smart contract which is specific. Which is encompassing all the manufacturers. So it's like a master smart contract which will have a list of all manufacturers and their connected devices. Okay, so that is the first thing they have to do. So they have to come and join in the network, shell out some cryptocurrencies. They have to pay some cryptocurrencies, enroll themselves, and they'll be connected to the IoT cloud. And the verifiable claim will be created. So now you will understand what actually a decentralized identifier and a verifiable claim here is. Okay. The next thing what happens is that an individual user, or a person who is trying to join the network will come and join in the IoT cloud. Okay, he'll come himself. He'll join the IoT cloud. Say, for example, if I buy a device, okay, I want to get it connected with the blockchain network. So after I buy the specific device, which is already in the list of manufacturers, I'm buying from that manufacturer, and I'm enrolling myself in the IoT cloud. So this IoT cloud will register my details. I have my own decentralized identifier, right? It will get all the metadata from me, and it will get all the metadata from the manufacturer, combine it will give you a verifiable claim or a verifiable credential, telling all the list of payloads, having all the metadata of who's the manufacturer, what is the part of network it is, and who is possessing it. So I am the owner of it, right? So I'll be having all the list of details. The next thing will be Wi-Fi provisioning or IP provisioning, where you connect to a device, correct, through means of an IP. IP is important. Either you connect through LAN or wireless. So wireless can be of different standards, like you can do it with Bluetooth or near field communication or with. So the important part here is how do you give the SSID username and passwords to the router. Say, for example, if I have to remotely log into my router, you can't simply pass the SSID username and password, which is vulnerable to everyone. It will be available to everyone. So that is where we use encryption methodologies here and record all of it with the digital decentralized identifiers. Okay. So the next thing will be device binding and verifiable credential. Okay, a simple process. Like I come here, I resolve this smart contract. So resolve here is nothing but the proof of work, the mining that is happening in the behind, and the resolution that comes out of it is nothing but the resolve here. So we solve for this smart contract, we adhere to the smart contract, we enroll themselves. So once you declare yourself as the owner of a specific IoT device, you will get a response, which is nothing but the response here, a hash code and a URI document where your document is stored, and every detail is stored in a IoT cloud. So this IoT cloud may be an AWS or Azure or IBM, whatever it is. So the important point here is essentially a decentralized identifier should remain on the blockchain. But what we are doing here is we are trying to store the decentralized identifier in the blockchain in terms of a hash, but the corresponding DID documents are stored in a remote cloud storage. Okay, it can even be an interplanetary file system. So if you come to Hyperledger Fabric, it will be an interplanetary file system where the storage itself is decentralized. Say like you have a PDF document, it won't be stored as such. No, the complete document won't be stored in a repository. Imagine that you tear it apart into 4 pieces and scramble it elsewhere, right? So you put it in 4 different boxes. So that is how it will store. It will store one chunk of data in one container and another chunk of data in another container. Likewise, you'll have multiple containers holding your data. So that is called interplanetary file system. That's quite secure. So in order to go with the normal cloud storage like AWS or Azure, whatever you wish, this is the mechanism. You hash the identifier, you store it in the blockchain. The corresponding DID document will be stored in the AWS storage with proper authentication mechanisms. Okay. So once you are done with the registration, you will have your own. So now, having said, the entire process is nothing but you enroll yourself, the manufacturer enroll themselves. After they enroll themselves, you buy a product from them. After you buy a product from them, you go and register yourself in the IoT cloud, saying I am the owner of this device, and a specific hash will be formed. And if you could look at the verifiable credential, it will be derived for you. Once you look at it, you will see all the metadata of who is the owner and who is possessing it, who is the manufacturer, and every detail of it. Okay, so this is the overall structure. So let me tell you a scenario where this is in terms of permissionless is what I'm speaking. So let me tell you a scenario where two people, Bob and Alice, we'll consider Bob and Alice. Bob wants to communicate with one of the IoT devices of Alice. Okay, so imagine two people are communicating with each other. Bob wants to control the what to say, the thermostat, or simply water sprinklers. Say, okay, imagine that Alice is out of town and she asks Bob to water her garden. So water sprinklers are highly automated, so it's connected among the Internet of Things. So what happens in a normal scenario, for not caring about the IoT security and so on, they'll simply give over the password or even the device itself to the neighbor, and they'll simply go on, which is vulnerable in future. It depends on what kind of the neighbor you have, right? So now the actual scenario of decentralization is a procedure where we'll follow. So first, what he'll do is Bob will get the DID, decentralized identifier of the device from Alice. Okay, that is available very much in the blockchain, which is nothing but a unique alphanumeric value, which is also called as an address. Okay, that will be given to Bob. So Bob, based on it, will try to resolve. Resolve here is nothing but, as I earlier said, consensus mechanism will happen whether you are a valid you are a valid transaction or not, and later you'll be given with the output, which is nothing but a block, and that is the resolution that you get out of it. So we cut all those steps here, and we come to the final step of resolution. Okay, so once you are resolved, it identifies you as a person in the blockchain, and it identifies that you carry a valid address, IoT address, that you want to communicate with. Now what Bob does is, after he gets all the resolution from the blockchain, he will have to pay some proof of stake, which is nothing but a cryptocurrency for it. So what he will do is he will get the payload, sign with his own private key and the public key of Alice, and along with the cryptocurrency that he has to pay for it. Okay, and he will sign it and send it to the blockchain platform, and the platform in turn will emit the data to the app, which will be notified to Alice, saying that Bob has requested to control this IoT and he has paid this much is what. See, the payment here is nothing but, no, you have to understand here, the payment that we do here is not for Alice, but for the proof of work that is being done. Say, for example, if you are a miner, in order to maintain the chain, in order to maintain the eternity of the chain, you'll have to keep on adding blocks to it, for which every transaction has to be verified, and the verification is done by any people who's interested in mining it, who's interested in verifying it, and those miners will get paid for the work they have done. So that is what you pay for. So once Alice sees a notification, she will accept it or reject it. It's up to her. So she will do a identification mechanism where she will verify for Bob's hash code. What if he's a valid identifier or not? She runs some check, and finally she approves it. Okay, so this overall mechanism happens in terms of a permissionless blockchain. So I hope you are clear about permissionless. Permissioned, I can tell you a very, very short stint of it. So permissioned is simply a contrast. It's completely opposite to permissionless. Okay, permissioned is better in some ways, where for example, you are employing a IoT technique with blockchain for a enterprise company, or for industrial purposes, then public won't be feasible because you can't expose all the data to public. So wherein a limited number of parties will participate, and they'll make the process happening. So here you don't have a overhead of doing a proof of work. You don't need to pay anything here. You don't need to involve any currencies here because you don't need to pay anyone. It's all based on consensus. Consensus is more of an agreement. It can be um, there are different types of consensus available. It can be proof of authority or proof of work. Proof of work is for permissionless, or proof of stake, or whatever it is. There are different consensus available. Along with that, you will apply some fault tolerance like Byzantine fault tolerance and PBFTs. There are other fault tolerances in order to avoid doing the repetitive work. Say like if somebody is trying to validate true transaction, and if someone else in the same time trying to validate the same, then there lies a friction, right? So it can be avoided based on Byzantine fault tolerance and PBFTs. So this is a typical architecture of a telecom ecosystem where you have a suite of IoT devices in the base. You could see here like weather forecasters, LED smart bulbs, and so on. A plethora of devices in the base platform. I hope you remember the pyramid that I showed you earlier in the previous slides. So all these devices come into play, and in between is where you have Hyperledger Fabric. Okay, Fabric is the base platform over which your complete application can be built upon. So this entire application can be built on Fabric platform, and whatever modules you have to incorporate, you can incorporate over here. So user consent management or CRMs or any analytics engines, AI, ML, or whatever it is, you can build on top of your Hyperledger Fabric platform. So the third component is a plug and play component where you can deploy any of the other platforms as well. Say if you want to use Hyperledger Indy, you can use here for identity, just trusted identity here, and for traceability, if you want to use Hyperledger Iroha, or if you want to use Hyperledger Sawtooth, you can use it as a plug and play module. It's highly modular, right? So you can on top of it is nothing but it's more centric on what type of use case you are focusing on. So that is where you will have a discretion of what plug and play concepts you want to use. Okay, so this is a complete. It's an overview of what you can do with Hyperledger, and here is a sample for an automobile industry where you have OSS and BSS services, operational and business services, right? So which is predominantly relies on CRMs, service requests, and imagine you have automobile sector, right? So automobile sector will have a lot of verticals starting from CRMs, services, suppliers, ancillary providers, raw material providers, and so on. So this is a complete module that is running on Hyperledger blockchain network, where these are different parties. So every party will enroll themselves in the network. Okay, so this is what happens in consensus basis. So Hyperledger Fabric, you need at least minimum of 3 people in order to make it work. You can't just do with 2 people. Then who will vote for you? Okay, this is completely on voting. So all the party join the network. So the point here is in permission, you know who are the parties who are joined, but in permissionless, you will never know who's the party you're going to communicate with. There is a major difference. And the performance wise, you don't have any blockers here. Your architecture will be seamless, and there won't be any performance or latency issues at all. So this is the network in which your complete modules will be built upon. So I can show you a simple screenshot of an IBM blockchain using IBM Watson. You could see here switch has been installed by an agent in Dallas. Okay, so in order to record that, the blockchain has recorded with the metadata giving agent name. So this is based on the digital identifier, decentralized identifier, and verifiable claim, which once the person has raised a ticket stating that he has completed the installation of a smart switch in a location at Dallas, So that has been recorded in the payload with the order ID, reference ID, and so on. Okay, this is a simple snippet of how the IoT works in the blockchain. Okay, and this is a typical example of IBM has their own brand, and they have a lot of developments happening in the food chain sector, agriculture sector, as well as in the logistics sector. So TradeLens is one such use case. You can go and hit the website and see for yourself. TradeLens maintains their entire fleet of services. They manage it with Hyperledger. Okay, so the consignment tracking, the temperature of the consignment, and where the geolocation of it, and where it is traversing, the entire data can be managed through blockchain. So TradeLens is what you can go and see for yourself. And the next thing is IBM Food Trust. So food trust, it's a typical journey from the farmlands to the user's plate, the consumer's plate. So until that, the entire journey is being recorded in the blockchain for audit, where you can check if you are, if you have bought vegetable, if it is fresh or not, based on the audit trail that you have. You can see based on the records that you have got in the blockchain. So, so there are no newcomers here. You could see a lot of enterprises, envisioning blockchain as one of their important use case, and they are adventuring into it. So, Vandop, Commonwealth Bank, Smart Electric Power Alliance, McKesson, Maersk is a container company. So all these prominent players are, entering into the field of identity and access management, because some of them, most people and most enterprise thinkers and anti blockchain evangelists, they think like blockchain is a overhead. It's not a overhead at all. It's a way of life, is what I would say, because in order to solve the present problems, it is very much difficult for people to maintain such humongous amount of data. See, Microsoft couldn't able to maintain its own customer base. That's why they don't even have data centers available to fit in Earth. They have data centers under the seas. They have over the hills. Okay, even one conglomerates or one corporation cannot hold the data of entire, billions and billions of people. We need self-sovereign identity is the future, is what blockchain would say. Okay, so IoTex is what I've already explained, but you can go ahead and visit the project in GitHub, and there are so many developer documentation tools and APIs which is available, and it's basically based on blockchain. You know what is blockchain? Blockchain is a platform. It's one of the DLTs, distributed ledger technology. There are other DLTs as well. So IoTex is based on blockchain, and they have their own middleware where they have developed cryptocurrency, where you have to buy those cryptocurrencies to do a proof of work, to pay for the proof of work. And on top of it, similar to Hyperledger, they have some services available in the form of APIs, where the dashboards can be accessed, decentralized storages is provided, smart contract tools are given. Like, in Hyperledger you have smart contracts written which is called chain code over there. Smart contracts are called chain code, and the rest are called smart contracts in other platforms. Those are written in JavaScript and Node.js and Go. And here you have something specific to Java or any open source, even Python or whatever it is. So it has libraries in different DSLs. Okay, the main it's I'm not sure if how many of you know this, but there is a new kind of DLD is coming up, and which is more promising as well. IOTA is one specific DLT which focuses on IoT. It's not only on IoT but on different aspects as well. IOTA is so peculiar, and it is kind of gaining huge traction these days. So what mainly it does is, a simple blockchain has a bottleneck. As I said earlier, it's a very linear way of progressing, right? So you will keep on appending blocks one by one. So for every transaction that is solved, you can pick up one block, you can solve it and add it to the line. So this keeps on adding as a line of beats. Okay, but IOTA is something different, where it is not a linear line, but it is a tangle. Okay, a tangle is nothing but a cluster. You could see a tangle here, right? So each and everything is connected with one another and multiple entities as well. And these tangles where you could see here in the rearmost or the rightmost ones are not connected. That means it's not validated yet. So the mechanism here is so simple. Here a user or if you commit a transaction, say if I commit a transaction, it won't be readily available in the block here. It will be solved for its validity, for the correctness. People will work in the behind. The miners will validate the transaction and add it to the block, okay, which involves proof of work. And based on some algorithms, the blocks get assigned to you, and you solve it and you submit it, right? There is a time seepage here, as well as there is a performance issue here. But here, what it does is, if you are submitting a transaction, say for example, if I am submitting a transaction, what I have to do is I have to solve for two other transactions. I have to verify two other transactions. Say if a new block is joining here, it has to solve two other transaction which is randomly selected. It need not be this and this. It can be even this and this block. Say if a new block is coming here, it need not solve for these two. It can solve for these two or these two, whatever it is. So the key takeaway here is, if you submit a transaction, you have to solve two other transactions. Likewise, you will form a interconnected chain which is performance agnostic. I mean, which is so seamless. You don't have any bottlenecks here, and the performance is super speed. And the more the number of transaction weightage is, they call it as a weightage. The sum of weightage, when the sum of weightage is more, it means the particular block is more and more valid. Okay, it's more and more trustworthy is what we can infer. It's not a proof that it means that, not like this doesn't have this have a least priority and this have a high priority, not like that. But the sum of weightage derived is based on that. Say for example, this particular block has an interconnected loop from here, 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 and here. So 1, 2, 3, 4, 5, 6. 6 of them, it has a weightage of 6. Okay. Likewise, these blocks have a interconnected threads, a very long trail of blocks. So this is a new practice that is happening. We are not at, and the main takeaway here is that there is no proof of work here. It's a zero. They call it as a zero priced blockchain, because you don't have anything as proof of work, and you don't need to pay for anything. It's a zero sum game. They call it as a completely free blockchain, and it is gaining more traction. Also, you can look further on this. Okay, so there are some prominent startups that are coming up in this space. In terms of trustless device identity, we have already seen IoTex, Hyperledger is one such. These are some startups which are coming up. So NXM, Uniquid, Autonomy, Ward, these are some disruptors. And we have Urbrick, Taxara, Sage, Smart, and so on for connected device security and interoperability and autonomy in different sectors. Okay. So this is my digital identifier. I'm just kidding.
Yeah,
There's
okay.
nothing as digital identifier here. You can contact me over mail. You can see my website. And all my blogs, social media will have a handle of RK Signer. So for any queries, you can reach me out. Thank you.
Thank you, sir. Thank you very much. On behalf of Management Executive Director, Principal, Department of Computer Science and Engineering, I convey my sincere thanks to our resource person, Mr. Sainath, for handling this session, Decentralized Identity and Access Management for the Internet of Things. I would like to express my thanks to all of you participants who are joining our FTP and make this event to happen successfully. Thank you, Sainath, sir. Thank you very much.
Thank you.
Thanks
Thanks
Thank
all.
you, sir.